Hello and welcome to Web Control for Drilling, Intervention and Workover. In this video hereafter, we will wrap up key points about MAASP and the EMW. What are they all about? Let's get started. First of all, let's define MAASP. What is it? It is the maximum allowable annular surface pressure reading on the choke pressure gauge or casing pressure gauge that doesn't break the weakest formation, usually at the previous shoe. And we can always work out the equivalent mud weight at the shoe from MAASP. And how to calculate MAASP and EMW? It all comes from the strength test at shoe. The strength test at shoe is either FIT leak-off test or extended leak-off test. How do you do it? At the time performing the strength test at shoe, you have the mud in the hole with the mud weight, with the current mud weight. And with the prognosed strength given to you by the scientist, the geologist, you can calculate and estimate how much is the maximum pressure you shall apply at surface. So with that maximum applied surface pressure you impose into the well at the time of strength test, you have the MAASP and the EMW. So your MAASP is the exact maximum surface pressure that you apply in the strength test. And your EMW, what is it? EMW is the strength of the formation at the shoe that is expressed in equivalent mud weight. It accounts for the total hydrostatic pressure of the mud column above the shoe plus the imposed surface pressure that you will just put into the well. You just adjust it into the well. Okay? That combination shall not break the shoe, shall not cause any losses in the shoe. So that is the strength at shoe, EMW. So it equates the current mud weight in the hole plus the surface imposed pressure divided by 0.052 divided by shoe TPD. Very simple and straightforward. And along the course of the drilling, if you change mud weight, you need to recalculate the MAASP. That's the rule for all drillers. Don't forget to do so. All right. Why you need to change mud weight? If you encounter increasing pore pressure, or you anticipate that reaching a certain depth, you will need to increase the mud weight to deal with the increased pore pressure. Here is a little bit of engineering perspective. It's called PPFG chart here. The blue line is the fracture gradient of the formation. And the red line is the pore pressure gradient of the formation. And this, for example, this line here is the TPD of your shoe. You're going to drill from this shoe to the next shoe depth. So at this shoe, pressure shoe, you have a leak-off test or FIT or extended leak-off test, whatever. With that strength test, you can use the same mud weight number 1 to drill from this shoe out. But before reaching this point here, you need to increase mud weight to deal with the pressure rank, the increment of the pore pressure. Similar here, you need to increase mud weight prior to reach the shoe depth, right? So that's the reason you need to increase mud weight. All right, and how to calculate the new MAASP? What is the unchanged? The unchanged is the EMW of the shoe. All right, so we start from it and start with it. Your new MAASP will be reduced if you increase the mud weight because EMW is unchanged and it accounts for the total hydrostatic pressure of the mud column above shoe. All right, now you increase the mud weight. That hydrostatic pressure is increased. All right, so then the leftover will be reduced, and that leftover is your MAASP. And this is how you calculate it. You take the difference between EMW versus the new mud weight times 0.052 times shoe TPD, not the well TPD. Just make sure you use shoe TPD at all time when you are dealing with MAASP or EMW. And this is an application in the event of well control situation while you are circulating out the influx. As long as the influx is below the shoe, the rule is you need to keep your casing pressure or your choke pressure below your MAASP. With your present mud weight in the hole, you work out the MAASP and mark it on your pressure gauge, your casing pressure gauge. You also need to mark initial shear casing pressure and your safety zone, your margin, safety margin of 50, 70, or 100 psi depending on your well. And also you calculate the Q mud and calculate the new MAASP with the new Q mud and mark it down. So as long as the bubble is still below the shoe, how do you know? By calculating your bump stroke. Okay? You know that your bubble is still below the shoe. You need to keep the casing pressure gauge below MAASP. Okay? Once the bubble goes above the shoe, then you can exceed MAASP without worrying breaking the shoe, because now the hydrostatic pressure of the mud column above the shoe is not so much, because the gas is expansion. It takes the place in here. One more very important note about casing pressure is that you shall not exceed 80% of the burst rating of the casing in the well. And for sure, you don't want it to exceed the rating of your wellhead or your BOP rating. Very simple. For the guys doing the workover wells, for case toe compression, because case toe compression is all dealing with cemented cased off. Okay, all the casing and production liner are cased off and cemented off and then perforated. So you don't worry about the MAASP and shoe. But what you worry is you worry about the surface rating of your wellhead equipment and the burst rating of your casing, because after 20 years, 30 years, the rating of those wells, those equipment are deteriorated much lower. For the guys doing workover on open hole compression, right now you worry about the previous shoe MAASP, because now you have a long open hole and then perforation, right? So you have the shoe cemented off, but now the shoe is also deteriorated after 20 years, 30 years, so the MAASP now will be reduced. So those are important notes, very vital, significant for the guys doing workover. And I hope you get something useful and helpful out of this clip. If you have any question or comment, just feel free to drop me a note in my email address. See you soon in the next video. Cheers.